Have you ever wondered how Netflix knows what movie to recommend next, or how your email filters out spam messages? The secret lies in machine learning. This invisible force is omnipresent, subtly influencing our lives every day. From predictive texting on your smartphone to the digital assistant that knows your music taste, machine learning is the invisible puppeteer in the grand tech show of our lives. Now, to truly appreciate this technology, we have to delve into the different types of machine learning. Imagine you're teaching a child to identify different fruits. You show them pictures, name the fruit, and they learn. This is similar to supervised learning. Just as a child learns from a parent or a teacher, supervised learning algorithms learn from labeled data. Picture this. You have a box full of apples and oranges, and you want your machine learning model to sort them out. To do this, you first provide the model with a training data set, where each fruit is labeled either as an apple or an orange. The model studies this data set, learning the characteristics of each fruit. Once trained, it can correctly classify new, unseen fruits into their appropriate categories. Supervised learning is like a diligent student, attentively learning from examples provided by a knowledgeable teacher. It's reliant on labeled data, where both the inputs and the desired outputs are known. This learning method is widely used in applications where prediction is key. For instance, think about email spam filters. They are trained using a data set where emails are labeled either as spam or not spam. The algorithm learns the patterns associated with spam emails during training and later applies this knowledge to filter out new incoming emails. Or consider a weather prediction model. It learns from historical weather data, where each day's weather conditions and the corresponding weather for the next day are known. The model uses this data to predict future weather conditions. Supervised learning, like a well-behaved student, learns from its teacher. But what if there is no teacher? Imagine a toddler exploring a room full of toys. They group similar toys together, even without knowing their names. This is akin to unsupervised learning. In the realm of machine learning, unsupervised learning is a method where the model learns from test data that has not been labeled, classified, or categorized. Rather than responding to feedback, the model identifies commonalities in the data and reacts based on the presence or absence of such commonalities in each new piece of data. It's like our toddler, exploring and learning without any preconceived notions or labels. This technique is commonly used for clustering populations in different groups, which is widely used for segmenting customers in different groups for specific intervention. Unsupervised learning also has the ability to identify key patterns, detect anomalies, and reduce dimensions. Picture a streaming service like Netflix or Spotify. These platforms use unsupervised learning to recommend shows or songs based on your viewing or listening history. It clusters similar types of content together based on factors like genre, artist, or even mood. The system doesn't know that a certain song is labeled as rock or pop. It simply identifies patterns and similarities in the data and makes a recommendation. Or consider a credit card company that uses unsupervised learning to identify unusual patterns or outliers that might indicate fraudulent activity. The system isn't told what fraud looks like. It learns to identify it based on patterns in the data. Unsupervised learning is like a curious child learning by itself. But what happens when learning requires a reward system? Imagine training a dog to fetch. You reward the dog each time it fetches correctly. This reward-based learning is similar to reinforcement learning. It's a type of machine learning where an agent learns how to behave in an environment by performing certain actions and observing the results or feedback from those actions. Think of it as playing a game of chess against a computer. The computer or the agent learns from each move it makes and the subsequent result. If the move results in a positive outcome, say, capturing one of your pieces, the agent gets rewarded. If the move results in a negative outcome, like losing a piece, it gets penalized. Over time, the agent learns to optimize its actions based on the rewards and penalties. It learns to make moves that maximize rewards and minimize penalties. This is the essence of reinforcement learning, the dance of reward and punishment. Now, you might be wondering, where do we see reinforcement learning in the real world? Well, it's used in a variety of applications, from self-driving cars, learning to navigate roads, to recommendation systems refining their suggestions, to robots learning to walk or perform complex tasks. Reinforcement learning, like a disciplined pet, learns from rewards and penalties. But is there a way to learn from experience? Just like humans, machines can learn in various ways, from supervised to unsupervised, and reinforcement learning. Each type has its unique approach. We've journeyed through the fascinating world of machine learning, unraveling the layers of its three primary types. Let's take a moment to recap and appreciate how these types, each with distinct characteristics, contribute to our technological advancements. We started with supervised learning, a realm where machines learn under the watchful eyes of their human trainers. Like students taking notes from their teachers, these algorithms learn from labeled data, making them popular in predicting outcomes. It's this type of machine learning that powers your email spam filters and weather forecasting apps. Next, we explored unsupervised learning, where machines are let loose on unlabeled data, left to find patterns and relationships on their own. They're like detectives, sifting through clues to crack the case. This type of learning is the brain behind your online shopping recommendations and those nifty customer segmentation models businesses use. Then we ventured into the exciting world of reinforcement learning. This is where machines learn like humans through trial and error. They're like toddlers learning to walk, stumbling, getting up, and trying again until they get it right. This type of learning is the force driving autonomous vehicles and game-playing AIs. Each type of machine learning plays a distinct role, yet they all share a common goal: to make our lives easier, more efficient, and more personalized. They're the invisible heroes behind countless applications, from medical diagnoses to financial forecasting, voice recognition to social media algorithms. The beauty of machine learning is that it continues to evolve, pushing the boundaries of what's possible. As we advance further into the 21st century, the influence of these learning types will only increase, making them an integral part of our everyday lives. So the next time you see a personalized ad or a movie recommendation, remember, it's all thanks to machine learning.